Hello, this is Dr. Prasad Patelam, my YouTube channel, My Intuition. After covering the Biology for Engineers, Research Methodology and IPR, IDT, SFH, Chemistry, now I am touching Physics. Okay, so Physics, this is only for understanding and as well as to find the applications, as I was a faculty of nanotechnology. Seen this application oriented part in my topics, therefore I found that this particular class series I'm giving not exactly for the exam point of view for the BPHYS Technology University students, but to connect the topics which are there in the syllabus to the high end for computer science stream students. This is given. Therefore, wherever possible, I am taking to the trying to connect it to the application part of that. Okay, so this particular module, laser and optical fibers, that everyone knows about that, heard about that. So we are going a little bit intense about the lasers and the optical applications, optical fiber applications. Now we know we heard about the word LASER, laser. It sounds like a very modern and high-tech term, but understanding it, it starts with a very solid foundation of the basic physics principles. So let us start from the beginning itself. The term laser, it stands for light amplification by stimulated emissions of radiations. So it is a device which generates the light through a very specific process. The primary difference between the regular light and the laser light, it is that the laser light, it is special, it is highly coherent, it is monochromatic, and it is very intense. So this unique set of properties of laser make it stand out in a comparison to the ordinary light source like the incandescent bulbs or the light from the sun. So now we'll see little bit deeper into the characteristic properties of a laser beam. The first point given, that is coherence. One of the most important properties of laser beam is the coherence. Coherence, it refers to the phase relationship between the waves of light, or in other term, if I say a coherent light wave is one where all the waves are in synchronized. They are in synchronized with each other, oscillating at the same frequency and in the same phase. Everything is synchronized. We call it as they are coherent. So there are two types of coherence, like the temporary coherence and the spatial coherence. Temporary coherence means that the light emitted by the laser, it maintains a constant frequency over time. This is crucial for the applications like the holography. You see the image which is given the particular image. It is a three-dimensional uh, presentation of an object using the laser light. So this is very important. This temporary coherence is very important for the applications like the holography or high precision measurements. Second one, that is spatial coherence. Spatial coherence means that the laser beam can be focused into a very small point or spread over long distance without losing its focus. Thus, the light remains tightly concentrated even over large distances. In contrast to the ordinary light, such uh, the ordinary light, like the ordinary incandescent light bulb, which is incoherent. It means that the light waves are random in both phase as well as and frequency. So, which is why the light from a bulb spreads out quickly and it lacks directionality, whereas because of coherence, the laser lights are they have directionality. Then comes the monochromaticity. This is second property which I chosen. Uh, Not I chosen, the property of a laser light. Monochromatic means mono means single, chrome means color. Therefore, it is one color. Monochromatic means one color. So a laser beam typically emits light of a single wavelength. So an example given here, laser light with a green one. So this image, particular image. Okay, whereas ordinary light it has got all the different wavelengths. Whereas the laser light it will be having one color. It may be green, it may be red, it may be blue, maybe yellow, like that. Single one color. Then we call it as monochromatic. For that is only one wavelength, because different colors are different wavelengths. So, for example, if a red laser, a red colored laser, it has a wavelength of around 650 nanometers, meaning that it only emits light of that exact wavelength. And this is different from the sunlight. The sunlight is a mixture of many wavelengths, and therefore it appears white for our naked eye. All colors combined becomes white. The narrow bandwidth of a laser beam is what make it so precise. Bandwidth means the distance kept for the light wave to pass. Bandwidth is the gap which is maintained so that light wave can pass, not the light as such. Light as such, what was seen, all waves are there. The width is so high, very too much length is there between the band. Bandwidth is so small, microscopic level it goes. The wavelength level it goes. It is so narrow that a particular color only passes through that, so that it becomes very precise. So this property is very important for the applications like spectroscopy, where we need a very pure and well defined wavelength of light to interact with the matter to get the images, the spectroscopic images of an object. Then third one, that is directionality. Other how it travels, the light waves. A laser beam, it is highly directional, meaning that it travels in a straight line with a little spreadness, or called divergence. There is no divergence at all. It travels in one straight line. So this is one of the reason why the laser, it can be focused on such small points or travel over very long distance without losing its intensity. Regular light sources such as the bulb or the sun, it emits light in all directions, which results in the spreading out of the energy, and it loses the energy quickly. But with the laser, the beam, it stays concentrated and pointed in a specific direction, which is why it is so useful in applications like laser pointers and communication systems. I think in between I said something wrong. That sunlight, it quickly it energy loses. No, sunlight it goes. Sunlight energy it consumes all the light. The longer wavelength it reaches the longer distances. But ordinary bulb, what the incandescent bulb, it cannot have that long direction. It is not there. It spreads out its energy very quickly. whereas laser light, it can have that particular long direction or specific direction, and that is the application. We have laser pointers as well as the communication systems, very long communication systems, not a long distance communication systems. So because of the directionality, we have that particular applications. Now the intensity, this is another defining characteristics of a laser beam. It is having high intensity. Intensity, it refers to the energy which is carried by the beam per unit area. The laser beams are highly intense. It means that they pack a lot of energy into a small area. Large amount of energy is kept in a small area, therefore it becomes very intense. So this high intensity is what allows the laser to used or having applications like the cutting materials, metal cutting or plastic cutting. Laser beams are used. It is used in surgery to uh, to heal the wound, or to heal the microbes, or even to make holes wherever needed, such applications. And it is also used in micro machining, preparing the machine parts which are micro in level. Ordinary the machine parts that we use, similar type of machine parts of micro size, to make it we are using the laser beam. Uh, it needed very high concentrated or high intense light beams are required to perform the task very precisely. So in fact, the laser beams are so intense that they can burn or they can melt materials when focused on, and this is precisely how the laser welding works. Even I have seen recently one of the YouTube video that in the China, they are using the laser beam to cut the trees, the sides of the tree which is about to fall on the electricity, the grid lines and all. You see, no need to climb, a person no need to climb the from standing one point. Is they are focusing the laser beam to the portion where they need to cut, and they are cutting from the ground. Okay, that is one of the application that I have seen. Then next point, that it is monomodal operation. Okay, high intensity and monomodal operations. Monomodal means straightforward, me and you and me, no one else in between. If it becomes two interaction, if I interact with the two direction, it becomes oligodynamic. If more are there, it become polymodal. So monomodal means straight, one to one. I am giving the information only to you. Only you are watching my YouTube video, no one else watching. No person many are watching. But still, I said uh, monomodal means straight away. Whatever you want to tell to me. I will tell to you. That type of interaction is monomodal. So a monomodal a laser, it has a single mode of operation. Single mode of operation, meaning it produces a single frequency and a single spatial mode of light. So in more practical terms, if I say, it means that the laser which is produced, or laser produces a beam with minimum divergence and uniform intensity across the entire beam. It does not split into multiple paths or change direction as it travels. That is the word meaning of monometer. Then comes the brightness, high brightness. High brightness, it refers to the ability of laser, or laser's ability to focus a lot of energy into a small spot. The brightness of a laser is, it is a combination of its intensity and focus. So laser, it can concentrate energy into very small area while maintaining their intensity. So this makes the lasers and ideal for applications like the laser cutting, in which the high amount of energy it is focused on a small spot to cut through the material. Then I want to show you the property of polarization. This is another interesting laser beam property of a laser beam. Polarization. Polarization is, it refers to the orientation of the light waves. In many cases, the laser light is polarized, meaning the oscillation of the electric field in the light is in a single plane. Single plane, just like if I keep a paper like this, paper means a single plane is there. In only in that plane the light moves, not moving here or there in a straight line. If it is like this, it goes like this. So that uh, this is a plane as well as this is another plane. So two different planes, but light moves in one plane, then we can say that it is a polarized light. Okay, so the image, it represents that light of different length are traveling, but when a polarizer is kept, then it is moving only in one particular plane. Because color differentiation is also given in the image. Okay, so this property, it is used, the polarization property, in the 3D movie projection as well as the laser scanning. Now, applications of these properties like the coherence, monochromaticity, directional high intensity, high brightness, polarization. What are these applications? In between, I said some of the applications. Here I have highlighted all the applications where these characteristics has been made use. The coherence and monochromaticity, these properties are very crucial in applications like the holography, where we need a precise, stable light for recording and reconstructing the 3D images. The directionality and the high intensity, this makes the laser very ideal for the laser cutting, laser pointers, barcode scanners, fiber optic communications. So this ability, or the ability to focus the beam precisely and maintain its intensity, is very essential in these fields. Then comes the high brightness polarization. These are used in the optical tweezers. Tweezers means again the cutter only. They are used to manipulate very small or tiny particles, micro level cutting tools. We call it as optical tweezers. It is again used in laser cooling and even the 3D projection. Okay. Now moving to the next topic, the interaction of radiation with matter. What is radiation? That everyone knows. It refers to the energy which travels through the space in the form of electromagnetic waves or particles. It can be, it is a package of energy actually. So this can be electromagnetic radiation, like the X-rays, or it may be a particle radiation like alpha or beta particles. So both are there. Wave nature is there, particle nature, both are there. So electromagnetic radiation, it includes a very wide spectrum of wavelengths, ranging from the radio waves at the long end and to the gamma rays, which are the short end, and the visible light what we are seeing, that is in the middle. So the type of radiation and its energy level, it depends upon the wavelength or the frequency. So now the next important question is what happens when radiations interacts with the matter. There is where the things are getting interested, or it becomes interesting. So type of interactions, a type of interactions when radiation comes into contact with matter, a variety of interactions occurs. These are all those interactions. First point, that is absorption. Absorption occurs when the energy of the radiation, it is taken up by the matter. Took the second image in that, the second one, absorption, it is mentioned. In case of electromagnetic radiations, it means that the material absorbs the energy from the incoming photons, which causes the atoms or molecules in the material to move to higher energy states. For example, when sunlight hits a black surface, the surface atoms or surface absorbs the radiation, which increases the temperature of the material. In lasers, absorption of energy is a crucial part of how we pump energy into the active medium to produce the laser light. Absorption spectrum that we have heard of, it is a every material, they have a very unique absorption spectrum which defines the specific wavelength it can absorb. So based on the absorption spectrum only we decide the property of that particular material. So this is the reason why some materials are transparent to certain wavelength of light, and they are become opaque. They are not transparent to other lights, other wavelength of light. Then second point, that is scattering. Radiation is redirected after it interacts with the matter without being absorbed. That is called scattering. The first image, in the image of the first one, which is showing that it is getting scattered. There are two types of scattering, the relay scattering and the Compton scattering. Relay scattering, it occurs when the wavelength of radiation is much larger than the particle in the medium. So it is responsible for why the sky appears blue. The shorter wavelengths like the blue light, it scatters more easily than the longer wavelength like the red. That means the wavelength of radiation is much larger than the particle which is present in the medium. Therefore, the scattering occurs. Because the wavelength, it passes like this waves, particles are very small. Some particles it crosses, some particles go and it will reflect. There is no absorption, nothing. It get reflected from portions. Scattering occurs, and therefore I think the image which is the fourth image, by mistake I said the reflection one. Then comes the Compton scattering. It happens when the high energy photons like X-rays, they collide with electrons. The photon loses energy and changes direction while the electron is ejected from the atom. That is called Compton scattering. So this scattering, it plays a very important role in applications like the radar systems, like the medical imaging, and even the fiber optic communications. This is used, but the scattering of light, uh, where the light it is scattered within the core of the fiber optics. Next one, that is reflection. Reflection, it occurs when the radiation, it bounces off the surfaces of the material. So it happens when the radiation, it strikes the surface at an angle which is redirected back into same medium. Okay, so the amount of reflection, it depends upon the material's surface properties. For example, a shiny or a metallic surface will reflect most of the incoming light, while if the surface is very rough, it may scatter it in multiple directions. So reflection is very crucial crucial principle in many optical devices like the mirrors, the telescopes, and even the laser, where we want to direct the light to a specific location. Then comes the transmission. Transmission, it is when the radiation it passes through a material without being absorbed or no reflection. So the transparency of a material, the transparency of a material is to certain wavelength determines whether the radiation is transmitted. For example, glass transmits the visible light, but it absorbs infrared radiation. That's why it become hotter in sunlight if you keep the glass, ordinary glass which you use to drink water, or even the window glass. Okay, visible light it transmits, but it absorbs the infrared radiation. Therefore, when it keep on absorbing the radiation, the light, it is converted into heat. Transmission of heat changes the energy form. The amount of transmission, it depends upon the material and thickness of the material. Some materials can transmit electromagnetic waves very efficiently, such as the optical fibers, which transmit light with minimum loss over very long distances. Now, how does the radiation energy it will affect the matter? So the way the radiation interacts with the matter, it depends upon the energy on the radiation and the type of matter. Some of the basic scenarios are mentioned here, like called as the radiation effects, mainly the photoelectric effect, excitation, ionization, and even the thermal effect. Thermal effect, just now I said with the glass. Photoelectric effect is the first effect. It occurs when the light or the electromagnetic radiation it strikes a material, and it removes or ejects electrons from the surface of the material. Light, the electromagnetic radiation, light form falls on the material, it ejects an electron on the surface material. So photoelectric effect, the term thus it connects. So the energy of the incoming photon must be above a certain threshold so that it can knock the electron freely. So this phenomenon, it is the basic basis for every devices, the devices like solar cells, solar panels, photovoltaic cells, which converts the sunlight into electrical energy. So it also fundamental to the working principle of the photoelectron spectroscopy. This is special spectroscopy to scan the images is called photoelectron spectroscopy. Then comes the excitation and ionization. When radiation interacts with the matter, it can cause electrons within atom or molecule to move to a higher energy level. If the energy is high enough, it can even ionize atoms, knocking an electron completely out of an atom. This is important in technologies like the X-ray imaging and the radiotherapy. So ionizing radiation, it has enough energy to break the chemical bonds and damage the living tissues, which is why it is carefully controlled in the medical application. So that's why in X-ray rooms, not everyone has got permission. Okay, so here it's clearly the image shows the energy form comes, light energy form comes. If it hits an electron and completely it becomes ionized, removed from that, becomes a charged particle. So here ions means we know it is a charged particle. If it is electron, it will be having negative charge, so it becomes ionized. Whereas the second term, that is excitation, means when energy comes, an electron from a lower orbit, means which is near to the nucleus, it gets excited and goes to a nucleus, a path which is at higher energy levels, which is called as excited. Got excited, got more energy, and jumped to a balcony. Okay, it become rich, and it got the seat in the balcony. So he is able to afford the seat at the balcony. Okay, there is no balcony or normal seating in atoms. Just I said, easy to remember. Excitation. Uh, People go to balcony. No, nothing like that. Thermal effect we are seeing next. Okay, thermal effect. The absorbed radiation can also lead to a thermal effect, raising the temperature of the material. It is very common in microwave ovens application, which I am telling. So where the microwave radiation, it heats the food by causing the water molecule to vibrate and increase its temperature. So similarly, the laser, when focused on a material, it can concentrate radiation to heat or even cut the material. That is called the laser cutting. Okay, schematic represent how the heat it can be taken and converted into the form like sunlight, getting the heat output. Now the key factors which are affecting the radiation or the radiation matter interaction. Still we are on interaction of radiation with matter. So there are several factors like first one, that is wavelength or frequency of radiation. The way the radiation it interacts with the matter, uh, it depends upon its wavelength or frequency, either wavelength or frequency. If you know wavelength, you can calculate the frequency. If you know frequency, simultaneously, this you know the equation. Okay, so low energy radiation such as the radio waves, it interact differently with the matter compared to a high energy radiation like X-rays. That you can decide by seeing the absorption spectrum of a material, or the absorption spectrum it defines which wavelength are absorbed and which are transmitted. Then comes the nature of the material, or the material properties. Different materials, they react to radiation in different ways. For example, metals, they are good conductors, and they tend to reflect most electromagnetic radiation, while the insulating materials, they might absorb more radiation. The atomic or the molecular structure of the materials, they play a very huge role. For example, the semiconductors, they have unique interactions with light, which is why they are used in devices like the photodiodes and even solar panels. Now comes the energy of the radiation. It's energy levels of radiation. High energy radiations like gamma rays or X-rays, they have enough energy to ionize atoms. In contrast, low energy radiations like the radio waves, They does not have sufficient energy to ionize atoms, and mostly it causes oscillations in the electrons of matter. Now some of the practical applications of radiation matter interaction: medical imaging, X-rays. X-rays are the very easiest example or prime example of radiation interacting with the matter in the medical context. So when X-ray it passes through the body, they are absorbed at different rates by different tissues. So this allows, because we know how much X-ray have been, how much intensity of X-ray has been passed, and how much it comes back, and whatever region it comes back. Based on that, we can create a three-dimensional images. Okay, so this allows the doctors to create a detailed image of the inner body, inside the body. X-rays are absorbed more by the dense tissues like bones, and very less by softer tissues like the muscles or skins. That's why we are getting X-ray images. We are getting the reflected image shows only the shape of our bones. Okay, so it is also used in telecommunications. The fiber optic, which is the interaction of radiation with the matter, that interaction it is used in telecommunication, like fiber optic communication. Uh, the light, usually the laser light, it is transmitted through glass fibers. The light undergoes total internal reflection inside only, incomplete reflection, we call it as total internal reflection, which allows it to travel very long distances with minimal loss. Then comes the laser technologies. Laser technologies, that in laser cutting or laser engraving, uh, intense laser beams are used, or they are absorbed by the material, which causing the localized heating. So the material can either vaporize, or the material will melt, or the material will burn, depending upon the intensity of the laser and the type of base material we have. With that, we can either cut it, or we can engrave. I can write my name using laser light on particular material. Means engraving, writing, or making images, drawing, engraving, making tools. Those are all comes under this application. Then comes the solar energy, solar panels, the photovoltaic cells, PV cells. They utilize the photoelectric effect, where the sunlight radiation it strikes the semiconductor material, mainly the silicon, and knocking the electrons loose. Electrons become free, so that it passes through external circuit, generating electrical current. Okay, still more are there. It's become a very long video. The next topic, that is the Einstein's A and B coefficient. I'm not going for the derivation part. Already your physics teacher will be teaching in class. Detailed other explanations I am giving, because that much time teacher may not get to give those explanations, because it is difficult for people to understand the derivation. So I'll stop this video here. This whatever the uh, uh, Einstein's A and B, and what are its applications, importance and applications of Einstein's A and B equations, and the expression for energy density. Actually I covered in the PPT slide here, but I am not getting enough time. Length become lengthier. I am tired. So please subscribe. Making too much effort to understand, to collect the material, to arrange it properly, uh, understanding it and explaining it with reference. Please do subscribe to my YouTube channel, My Intuition 4865. You are a very good boy or a very good girl if you are sharing it to others, and have a nice day. Thank you very much.